Hey guys, I'm Sir O, your teacher on the go. Kung bago ka pa lang sa channel ko, don't forget to hit the subscribe button and hit the notification bell. Today's video lesson for Statistics and Probability is all about Central Limit Theorem. Central Limit Theorem. As the sample size increases, the mean of the distribution approaches a normal distribution and its variability decreases. Take a look on this illustration. This is a distribution of weight of rabbits. On the first figure, we get the weight of 20 rabbits. It shows that the density curve of the means cannot be described yet as the sample are limited and the spread of the mean or variability is wider. On the second figure, we get the weight of 200 rabbits. Although the curve of the samples is getting slightly normal, but the spread of the mean or variability is still big or wider. We need to achieve small variability or small spread. To achieve it, we need to increase our sample. Take a look at figure 3. We get the weight of 2 million rabbits. We can see that the mean of weight of rabbits are constricted on the center, which is 5 pounds. Some mean are on the left side, which has a smaller weight, and some are on the right side, which has a larger weight. The curve gets normally distributed, and the spread is smaller. It explains that as the sample size gets larger, the sampling distribution of the sampling means will approach a normal distribution, and the variability or the spread of the curve decreases. Standard error of the mean. The standard error of the mean measures the degree of accuracy of the sample mean as an estimate of the population mean. It is also known as the standard deviation of the sampling distribution of the sampling mean, denoted by lowercase sigma subscript x bar. Formula: where lowercase sigma is the population standard deviation and n is equals to the sample size. Example: determine the standard error of the mean of the sample size of 5 given the population standard deviation of 30. Round up your answer to the nearest hundreds. Using the formula for the standard error is equals to standard deviation over square root of the sample size. Solution: in our given, we have sample size is equals to 5, standard deviation is equals to 30. Substitute the given to the formula. We have 30 divided by square root of 5. Standard error is equals to 13.42. Central limit theorem is important because it teaches researchers to use a limited sample to make intelligent and accurate conclusion about a greater population. It also justifies the use of normal curve method for a wide range of problems. Furthermore, it justifies the use of the formula Z is equals to sample mean minus population mean over population standard deviation divided by the square root of the sample size, where Z is equals to Z score. If you could remember, we already introduced Z-score formula in the previous video lesson. This formula. So the question is, when do we use these two formula? Answer: it is depending on the given and what is being asked in the question. Let us put it in an example for better understanding. Example: assume that the variable is normally distributed. The average time it takes a group of senior high school students to complete a certain examination is 46.2 minutes, while the standard deviation is 8 minutes. What is the probability that a randomly selected senior high school students will complete the examination in less than 43 minutes? Follow-up question. If 50 randomly selected senior high school students take the examination, what is the probability that the mean time it takes the group to complete the test will be less than 43 minutes? Here are the steps in answering this type of question. Step 1. Identify the parts of the problem. Given population mean is equals to 46.2 minutes. Population standard deviation is equals to 8 minutes. And the sample mean is equals to 43 minutes. And we are looking for probability that the student will complete the examination in less than 43 minutes. Step 2. Use the formula to find the z-square. We have two formulas in finding the z-square. In the first formula, it has a sample size. In our given, we don't have sample size. So, we are going to use the second formula. Z-square is equals to sample mean minus population mean over standard deviation. Substitute the given. Z-score is equals to negative 0.40. Step 3. Use the z-table to look up the z-score you calculated in step 2. Z is equals to negative 0.40 has a corresponding area of 0.3446. Step 4. Draw a graph and plot the z-square and its corresponding area, then shade the part that you're looking for. Probability of sample that is less than 43. In our example, it is between 0 and negative 1 because we have z-score equals to negative 0.40. Since we are looking for less than 43 minutes, the shaded parts will be on the left part of 0.40. Step 5. If you are looking for a less than area, the area in the table is the answer. Therefore, the probability of having less than 43 is equals to 0.3446 or 34.46%. Therefore, the probability that a randomly selected senior high school student will complete the examination in less than 43 minutes is 34.46%. Now, let us proceed to the next question. First step is to identify the parts of the problem. Given population mean is equals to 46.2 minutes. Population standard deviation is equals to 8 minutes. Sample mean is equals to 43 minutes. And the sample size is equals to 50 students. We are looking to the same probability having less than 43 minutes. Step 2. Use the formula to find the z-score. We have two formula in finding the z-score. The first formula has the sample size. So, we are going to use the first formula. Z-score is equals to sample mean minus population mean over population standard deviation over square root of sample size. Substitute the given. Z-score is equals to negative 2.83. Step 3. Use the z-table to look up the z-score you calculated in step 2. Using the z-table, Z is equals to negative 2.83 as a corresponding area of 0.0023. Step 4. Draw a graph and plot the Z-score and its corresponding area. Then shade the part that you're looking for, the less than 43. In our example, it is between negative 2 and negative 3 because our Z-score is equals to negative 2.83. Since we are looking for the probability less than 43 minutes, the shaded parts will be on the left part of negative 2.83. Step 5. If you are looking for a less than area, the area in the table is the answer. Therefore, the probability having a less than 43 is equals to 0.0023 or 0.23%. Therefore, the probability that a randomly selected 50 senior high school students will complete the examination in less than 43 minutes is 0.23%. That's all for today. Thank you for watching. For more video lessons and tutorials updates, don't forget to click the subscribe button and hit the notification bell. Muli, I'm Sir O, your teacher on the go. Adios, amigos!